Hi all. So in this video we are going to learn about one more algorithm, page replacement algorithm called MRU. So this is just opposite to what we have learned in LRU. So we can say this as we are replacing the most recently used pages. So in LRU we were replacing the least recently used, and in MRU we are replacing the most recently used page in case of a page fault. Okay, in case of page fault. Now, what does that means when we say that it is just opposite to we see in LRU, okay, least recently used. So let's see this with an example. So let's first consider that we have a memory with 4 frames, and let's consider that we have the same string that is we considered with LRU. So this is one reference string 701203042 303, then it is 212 017 and 01. So this is the reference string, the order in which the CPU is does requires the pages or demands the pages. So in this sequence the CPU is requesting the pages. So this is known as the reference string, right? So it is, I believe it is the same. Let me cross check. 701203042 3303 and 212, then we have 017 and 01. Okay, so let's say we have 4 frames in our main memory, and let's see what is the total number of page fault when we use this MRU page replacement algorithm. So at initially all the frames are empty. So if the CPU requires page number 7, so it is a page fault because nothing is present here. Then it requires 0, page fault. Then it requires 1, it is also a page fault. Yet now we are not following any algorithm because already the frames are empty. So page 2, page fault. Now it requires 0, so already we have a 0th page present, so it is not a page fault. Now we need a 3, and all the frames are already occupied, so we need to follow page replacement algorithm. And in most recently used page algorithm, we would be replacing the page which is most recently used. So recently we have used all these pages 2107, right? However, we use this 0th page most recently, I mean just use. So we will be replacing 0 with 3. Okay, and this is also a page fault. Now if we need again 0, so what happens that we will be replacing again most recently used page. So most recently page used is of course 3, so we will be replacing 3 with 0, right? So it is a page fault. Okay, now let's say we need to access page number 4 and it is already filled, so we need to replace the most recently used page. So out of 0 1 2 and 3 7 most recently used page is of course 0, so we will be replacing 0 with 4. And this is also a page fault. So now we need 2, so no need to replace any page, it is already present, no page fault. We need 3, so now we will be replacing the most recently used page, and that is 2. So 2 will be replaced with 3, and 147, and it is a page fault. Now we need a 0, so we will be replacing 3 with 0 because 3 is the most recently used page among all. So 0 and 1 and 4 and 7, so it is a page fault, right? Now we need again 3, so again we will be replacing 0 with 3, and 147, and it is a page fault. Now we need 2, and if you see here 2 it is not present, so we will be replacing 3 with 2, and it is a page fault. Now we need a 1, so 1 is already present, so no need of page fault. Now we need 2, 2 is already present, no page fault. Now we need 0, so out of 2147 we will be replacing 2 with 0 because it is the most recently used page. Now we need 1, so 1 is already present, no need to replace any page. Now we need 7, 7 is also already present, no need to replace 7. 0, already present, no need to replace any page, and then 1 is already present, no need to replace any page. So altogether number of page fault in MRU algorithm is 4 plus 4 8 plus 4 12, right? So altogether number of and it is a very simple algorithm. Here we are just replacing the previous page because it is the most recent use page, right? So it is very simple in this case. But if we say in contrast to this we have LRU, so we have to search which page is last we use, I mean among all the pages present in the frame, which is the least recently used, which we referred much earlier. Okay, so that we have to replace, so we have to scan down. But in this MRU, it's this algorithm implementation is very simple. You are just replacing the previous page because it is the only page that is most recently used, right? So just in contrast, I'll be illustrating an example of LRU as well. But let's first see that if we have three frames available in the memory and we have the same reference string, so how many page fault does it incurs? So let's rewrite the same reference string, that is 701 203 203 042 303 042 303 212 212 017 and 01 017 and 01. Now let's start with this. So 7 is not present, it is a page fault. Then we need 1, 0, it is also a page fault. Then we need 1, it is also not present, so it is a page fault. Now we need 0, so we already have no page fault. Then we need 3. Now we need to replace a page which is most recently used, so we will just replace the previous referred page, that is 3. So it is as easy as that. So this is a page fault. Right, now we need a 0. Already we referred the most recent use page is 3, so 3 will be replaced with 0, and this is a page fault. We need 4, so 0 is the most recent use page among all these, so we will be replacing 0 with 4, and this is a page fault. We need 2, so 4 is the most recent use page, so 4 replaced with 2, and this is also a page fault. Now we need 3, so in this case 2 is the most recent use page, we will be replacing 2 with 3, and it is a page fault. Right, now we need 0, so 3 we will be replacing with 0, right, and it is a page fault. Now we need 3, so again we will be replacing 0 with 3, and it is a page fault. Now we need 2, so we will be replacing 3 with 2, and it is also a page fault. We need 1, so no need any replacement, it is already present. Then we need 2, so no need to replace, it is already present, no page fault. Then we need 0, so we will be replacing 2 with 0, and it is a page fault, of course. Right, then we need 7, I'm sorry, when we need 1, it is not a page fault because we already have this. Then we need 7, no page fault, we already have this. Right, then we need 1, no page fault, we already have this. Okay, and last one is 7. Okay, it's the last one. So here number of page fault is equal to 4 plus 4, right? 4 plus 4, and then plus 4 are 12 only. That's not possible. How is that? mm, how is that possible? 701, I think I just did something wrong. I forgot this part, right? So I just forgot this part. Seven after 701, we need 2 here, right? Okay, let me just do it again. I think I just forgot. Just let me redo it again because this string I just forgot. Okay, so we need to make a note of all these referred string, otherwise we will end up. Okay, let me erase it, and we will do it in some time. So whenever you are trying to make it, just look at every string. So, or either it will be a good approach if you put all the strings in the, like this, like what I'm trying to show in just few seconds. Just give me some time. Okay, fine. Let me change it. So yeah, what I'm trying to say is we have three frames. Okay, let me start with 7. So 7 is a page fault. Okay, then we need a 0. 0 is also a page fault, right? Then we need 1, which is also a page fault, definitely, because it is not present. Now we need 2. This is what we missed. So out of 107, we need to replace the most recently used page, that is 1. So we are replacing 1 with 2, and here is 0 and 7, and it is a page fault. Now we need 0. So we will be replacing which one? We need to replace the second page, because this is the most recently page used here. So we will be replacing 2 with 0. Okay, sorry, we no need to replace here, 0 already present, right? So it's 207, no need to replace. So 3, now comes the 3. So in 3 we have to replace 0 with 3, because we don't have 3 present, so it is a page fault, right? Then we need again 0, so we need to replace again 3 with 0, and 2 will remain the same, it is also a page fault. Then we need 4, and we need to replace 0 with 4, and it is also a page fault. Now we need 2, so 2 already present, no need to replace any string. We need 3, so we will be replacing 2 with 3, it is a page fault. Now we need 0, and 3 is the most referred page, so we will be replacing 3 with 0, and this is of course a page fault. Now we need a 3, so we will be replacing 0 with 3, and this is also a page fault. Now we need 2, so we will be replacing 3 with 2, and it is a page fault. Okay, then we need 1. So out of these 2, 4, 7, 2 is the most referred page, so we will be replacing with 1, 4, and 7. So this is also a page fault. Then we need 2, of course, then we need to replace this 1 with 2. So 2, 4, 7, right? So this is also a page fault. Now we need to have 0, and we have to replace 2 with 0. So 047, so this is also a page fault. Now we need 1, so 0 will be replaced with 1, and 4 and 7, so this is also a page fault. Then we need 7, no page fault for that. Then we need 0, so we will replace 1 with 0. So 047, right? So this is one more page fault we incurred here. Now let's see about 1. So again we need to replace with 0, and it is just a second. We have 7. So it's important to write every part, why I'm saying. So 147, just a second. Yeah, so here we were replacing 0 with 1. Okay, and it is 147. Now we have 7, so 147 we already have, no page fault here, right? Now we require again 0. Okay, so we will be replacing which one? We will be replacing 7 with 0, right? And 4 and 1, So this is one page fault. And for 1, we don't require to replace anything because it is already there. So 140. So now total page fault is 4 plus 4, 8 plus this 4, 12, and then this 4 is number of page fault is equal to 16. So altogether we incurred 16 page fault. So this is all about MRU scheme, which is just opposite to LRU, and LRU just we saw in the previous video. So that's all for this particular video, and here is how I'm closing this part. So if you do have any comment or question, please do like, share, and subscribe, and comment in your comment section. Thank you.